Okay, so welcome to our last lesson on trig equations, and let's dive straight in. We're going to go over these four that we asked you to try. If you haven't tried them yet, then please try them. Okay, this first one, we first need to just isolate the trig ratio. So we're going to subtract 1 from both sides. That's going to give us 2 sine theta over 2 equals minus 1. Next up, we're going to divide both sides by 2. So we get sine of theta over 2 is negative a half. Next up, this is a vanilla flavor trig equation. Next up, we go to our calculator. We know we want answers in quadrant 3 and 4. And the key that we're going to use to get into those quadrants, we're going to undo sine of positive a half. Remember, we never put the negative value into the calculator. We get 30 degrees. We get into quadrant 3 by going 180 plus 30. Remember, we only use our horizontal axis. And we get into quadrant 4 by going 360 minus 30. 330 degrees. Each of these can have 360 added to them as often as we like. Right, but remember now that this is not theta, this is actually theta over 2. So both of these equations, to find theta, we're going to need to multiply through by 2. So our final answers are theta is 420 plus 360k, or theta is 660, 330 doubled, 660. Sorry, I've messed that up. It's not 360k, it's 720k, right? So this one's not 360k. It's in fact 720k. And what do we know about k? Well, somewhere we got to squash it in. K is an element of z. Right. The next one, we've got tan equal to tan. Those are cool. That's very straightforward because we're just going to go theta plus 20 degrees equals 2 theta plus 180k, right, with k an element of z. And the last thing we're going to do is just solve for theta. We're going to subtract 2 theta from both sides. That will give us negative theta plus 20 degrees is 180k. Next up, we're going to subtract 20 from both sides. So negative theta is negative 20 degrees plus 180k. And lastly, we're going to divide both sides by negative 1, all the terms. 20 degrees minus 180k. And that's our general solution for that one. Okay, the last, or second last one, we've got cos and sine in the same equation, but different angles. So we need to change one of these into the other, right? Let's change this one to 90 minus. So let's change cos of 3 theta to sine of 90 minus 3 theta. And this one, we've got sine of 2 theta. Now, when we've got sine equal to sine, either the two angles are equal, all right, plus 360k, or the other alternative is that one of the angles is 180 minus the other angle, plus 360k. So those are our two possibilities. And now we simply need to solve for theta. Subtract 2 theta from both sides, we actually get negative 5 theta. If we subtract 90 from both sides, we get negative 90. When we divide both sides by negative 5, we get 18 degrees plus 368 divided by 75 by 5 is 72. Okay. Or here, if we add 2 theta to both sides, we've actually got a negative theta. Subtract 90 from both sides, we've got 90. When we divide through by minus 1, we get negative 90 degrees minus 360k. Right. Both of these, k is an element of integers. Right. And the last one, is a trinomial. Okay, let's see if we can. Well, no, it's not straight away a trinomial. We're going to first have to switch sine squared out. Remember that sine squared theta is 1 minus cos squared theta. So what we're going to need to do is substitute that into there. Right, so our equation is actually going to look like 6 1 minus cos squared theta plus 7 cos theta equals 3. Right, it requires a little bit of tidying up. We're going to get negative 6 cos squared theta plus 7 cos theta. We've got a minus 3 and a plus 6. It's actually going to be plus 3 equals 0. Let's divide everything through by negative 1. That's going to give us 6 cos squared theta minus 7 cos theta minus 3 equals 0. And this now factorizes to 2 cos theta and cos theta and 2 cos theta and 3 cos theta, a minus 3 here to give us negative 9, and a plus 1 here to give us plus 2, and there it is. From this one we get cos theta is 3 over 2. Now cos theta is 3 over 2 is impossible, alright? If you try and undo cos of 3 over 2, you get an error, and the reason you get an error, remember that cos never gets bigger than 1. Okay, so that's impossible. But the other one definitely has solutions. The other one says that cos theta is negative a third. 3 cos theta equals minus 1. Cos theta is negative a third. That definitely has solutions. We need to find a key angle. We know we want cos to be negative. Cos is negative in those two quadrants. We're going to need to pull up a calculator. Right, so undo cos of a third, not negative a third, just a third, and we get 70,5 degrees. So our key is 70,5 degrees. To get into the second quadrant, remember we only use the horizontal axis. 180 minus 70,5, that is going to be 109,5 degrees. All right. Or 180 plus 70,5, 250,5 degrees. So that's what theta is going to equal. And each of these can have 360 added or subtracted as often as we like, as long as k is an integer. Okay. Right, now in this question, and in fact, in some of the previous questions, we've used an identity. We've used the two identities that we've come across so far. And those two identities are that tan is sine over cos, and that sine squared plus cos squared is 1. The proofs of those are really straightforward, right? In this diagram, we know that sine theta is our y value over our r value. And we know that cos theta is our x value over our r value. So if we are to take sine theta and divide by cos theta, what we're going to have y over r divided by x over r. And when we take y over r and we divide by x over r, remember how we divide fractions, we tip and times, we get y over r times r over x. These r's can divide out as opposed to cancel. We don't really like the word cancel. When you cancel something, there's nothing left. All right? And so we end up with y over x. Now y over x is just tan theta. So there we have it. We've proved that identity, the one that we've been using. Let's prove the other one that we've been using, and that is that sine squared plus cos squared is 1. All right? Once again, exactly the same thing. We know that sine theta is y over r. And we know that cos theta is x over r. So sine squared theta plus cos squared theta is actually going to be y over r all squared plus x over r all squared. Now, when we square a fraction, do we square the top or the bottom or both? Absolutely, we square both. So we've got y squared over r squared, and this one's x squared over r squared. They're the same denominators, so we can add them. We get x squared plus y squared, or y squared plus x squared, over r squared. But, I'm going to write it over here. What do we know about x squared plus y squared? Well, because this is a right-angled triangle, we know that x squared plus y squared is actually equal to r squared. So what we've actually got here is r squared over r squared, and lo and behold, r squared over r squared is 1, and we are done. We've proved it. Okay, it makes sense. It always makes sense. All right, now we've seen that if sine squared plus cos squared is 1, then we know that cos squared is 1 minus sine squared, and sine squared is 1 minus cos squared. What we're going to do now is we're going to ask you to try and prove, and we'll do one together, some identities. All right, and the trick really is to know your basic identities very well. We only know 2 so far. That's the tan is sine over cos, and that sine squared plus cos squared is 1. We never work with both sides together. That's what we're trying to prove. So we work with the left-hand side and the right-hand side. And if necessary, we work with both. Okay, and we've got a few strategies here. One thing is to replace everything with sine and cos. All right. If we've got multiple terms, we can combine them. Sometimes we need to factorize. All right, but ultimately, it's just about practice, practice, and practice. Okay, to get better and better at these. Let's dive straight in and try one together, and then we're going to ask you to try one. Okay, first up, we're just going to simplify a few things. All right, so what do we know about tan? Well, we know that tan is sine theta over cos theta. So now we've got sine theta over cos theta, that's tan theta, and we're going to multiply by cos theta. Cos theta as a fraction is just cos theta over 1. The cos thetas can divide out, and we're left with sine theta. Right, what about the next one? Cos theta 1 plus tan squared theta. Now remember, one of our strategies was to replace tans with sines and coses. So let's try that. This is going to equal cos theta, and then here we've got 1 plus sine theta over cos theta all squared. So sine squared theta over cos squared theta. Now when we multiply cos theta in here, we're going to get cos theta, all right, and here we're going to get the cos is going to divide out, okay, and we are in fact going to get one of the coses is going to divide. We're going to get sine squared theta over cos theta. Okay, now, maybe not too obvious here, but we're going to add these two fractions. Okay, to make this one a denominator of cos, we're going to need to multiply the bottom by cos theta. And if we multiply the bottom by cos theta, so we're multiplying 1 by cos theta, we must multiply the top by cos theta. We get cos squared theta. This one is already over cos theta, so we've actually got sine squared. Now they're the same fraction type, we can add them, and we get 1 over cos theta. That's our final answer. Okay? The last one here, we haven't left much space. We don't need much space. what is cos squared of an angle plus sine squared of the angle? It doesn't matter what the angle is. Halala, it's just 1. Okay, now we're going to ask you to try these two questions. Pause the video, try them, and we'll go over them. Okay, so on the left-hand side, we've got two terms. Let's add those two terms. Let's make them both a denominator of sine theta, open bracket, 1 plus cos theta. Okay, now, that fraction there, the first fraction, to get it from this denominator to this denominator, we need to multiply the bottom by sine theta. If we multiply the bottom by sine theta, we must multiply the top by sine theta. So that is sine squared theta. That fraction there is exactly the same value as this fraction here. Right, now, the next fraction has got a sine theta on the denominator, and we want to get it to the same fraction type. So we're going to multiply the top and the bottom by cos theta plus 1, or 1 plus cos theta. So we've got a sine theta, and we're going to multiply by 1 plus cos theta. If we do that on the bottom, we've got to do that on the top as well. So on the top, we've got cos theta, 1 plus cos theta. Now, the big advantage of this question, of what we've just done rather, is we've got the same denominators. Now we can add these two terms. And I should have said this up front, but the reason we want to add these two terms, on the right-hand side there's only one term, and on the left-hand side there are two terms. Okay, so let's now add these two things. They've got the same denominator, so on the denominator we've got sine theta, 1 plus cos theta. On the numerator, we've got sine squared theta plus cos theta plus cos squared theta. Now, if we look at where we want to get to, our right-hand side is actually 1 over sine theta. So that's where we want to get to. We want to be able to say that equals right-hand side done. Okay, now if we have a look, we've got a sine theta on the bottom already. That's great. But we don't want this 1 plus cos theta. So ideally we need 1 plus cos theta on the top. And there it is, because there, that piece plus that piece is just 1. So in fact, what we've got now, if we add the sine squared and the cos squared to get 1, we've got 1 plus cos theta. And on the bottom, we've got sine theta into 1 plus cos theta. And now, what can we do? We can not cancel. We can divide the whole of the top by 1 plus cos theta. Goes in once. And the whole of the bottom by 1 plus cos theta. And we end up with 1 over sine theta, which is our right-hand side. Okay, we haven't left ourselves a lot of space to do the last one, but let's see how you went with that. So, the left-hand side, and again, let's add these two fractions. Okay, you might say they're not both fractions, but the left-hand side is actually equal to cos squared x over sine x. Now this fraction is actually sine x over 1. Okay, so what must I do to the denominator of this to make it a sine x? I must multiply by sine x. And if I do that on the bottom, I must do that on the top as well. So sine x times sine x, I get sine squared x. Now these have got the same denominator. I can just add the numerators. Cos squared x plus sine squared x. And as we write that down, we say, oh, I know what that is. That's just 1. And so I get 1 over sine x. And 1 over sine x is our right-hand side. We must always end with equals right-hand side if we started with the left-hand side. Sometimes we'll start with the right-hand side, but normally we start with the left-hand side. Sometimes we'll work with both. separately with a line down the page, right? And we'll get them both to the same thing. And then we can say left-hand side equals right-hand side. Right, there's a whole lot more on the next page. There's in fact 4 more on the, and in fact 4 more on the following page. So there's 8 more for you to try before we see you next time, when we look forward to going over them. Thanks and have a great day.